Good morning, everyone, and welcome to the first of this week's webinars hosted by Rockflow Dynamics. My name is Joanne from the RFD Aberdeen team, and today I'm hosting this session with my colleague Annabelle, who is our support reservoir engineer from the Madrid office. Thank you to everyone who's joined us today. We hope you're safe and well. RFD teams across the world are continuing to support our tNav community remotely, so if you require any assistance, just get in touch with us via the usual method. Best place to keep up to date with RFD activity is our LinkedIn page, so make sure you're following to hear all about upcoming webinars and other tNav updates. Welcome. If you haven't joined one of our webinars before, this is how it will work. All of the attendees today will have their microphone automatically muted. So if you would like to ask a question, please use the window in the control panel on your screen and we will answer as many of those as we can at the end. If we don't have time to answer your question live, we will follow up with you after by email. The session is being recorded and we'll also upload that to our YouTube channel. And if you'd like any more information on anything, you can email us at asktnav@rfdwn.com. In today's presentation, Annabelle is going to demonstrate how to use the well placement tool in an optimization workflow to generate wells following different development schemes based on objective function configurations. We have a variety of webinar topics over this 4-week phase. The last 2 week sessions are available to watch on our YouTube channel. And we're currently planning the next phase. So if there's any topics that you'd like to see, you can complete the survey at the end of the webinar or just drop us an email. So as I just said, we are covering a wide range of topics from the integrated workflow inside tNavigator. So if there is a functionality that you haven't used before and you'd like to hear more about it, just get in touch with us for more details and some trial licenses. So now I will hand you over to Annabelle to begin the presentation. Thank you, Annabelle.
Thank you, Joanne, and welcome everyone again. Thank you very much for joining today. My name is Annabelle Blanco. I'm part of the RFD team based on Madrid in Spain. As Joanne mentioned, today we'll be talking about how to perform a well placement optimization approach based on well pattern design. So an overview of the agenda today. First, we will start with a brief description of the well patterns, how we can design them, and how we can optimize them. Then we will see a demo showing this procedure in tNavigator. And finally, we will have a couple of minutes for questions. In this session, we will use the Model Designer and the HAM and uncertainty models within tNavigator. So what are well patterns? A well pattern is a schematic 2D projection of well location. It is based on a vector which has 2 arrows, one in the X direction and the other in the Y direction. Then, wells are located in a relative position to the borders. Later on, this pattern is repeated along all the area of interest. As we all know, we can find several popular patterns in the literature, like 5 spot, 7 and 9 spot, as well as direct line drive and staggered line drive, that have been used widely in the planning of water flooding schemes. So for this task, we have the well placement tool in the Model Designer model, where you can find several predefined well patterns for vertical and horizontal wells. And also, you can add your own pattern configuration using custom distribution pattern if you desire. So what to optimize? You can optimize the location and the number of wells by changing the arrow length and the angle of the vectors. You can optimize trajectories of deviated wells by adding parameters like azimuth angle and distance from the roof. You can optimize perforation by setting limits or changing the length itself. You can combine it as well with other features as geological and dynamic uncertainties by using the workflow editor. So for today's demo, the main parts are going to be, first, how to use the well placement tool in tNavigator, followed by optimization setup. We are going to add parameters into the well placement tool and combine it with group control variables, and then we are going to optimize it. And finally, we will analyze the result using HAM and uncertainty model in order to pick the best case and send it back to Model Designer. So let's start showing how the well placement tool works. This is the main window of tNavigator. Probably you are familiar with it. I'm going to open a project I have for this example in Model Designer. Here it is. Let's take a quick look at this model we are going to use today. Let me activate the stoic. So we can see it has around 50 million of cubic meters and a size of 32,000 blocks. So before using well placement tool, it needed to create the area of interest. So for this, I'm going to create a polygon using edit curve in the toolbar. I'm going to draw lines, keeping a security distance from the borders and from the fold. I'm going to provide a name. And then if you want to add regions, like for example, I want to add the left side of the reservoir, you click on Add New Component and you draw it in the same way. So that's it. Now we can open the well placement tool from the toolbar. Here it is. By default, it's going to show the wells using the last configuration. You can see that if I change the polygon, let's say for right side, which is only for the right side, the left side is going to be empty. If I take it back to the whole reservoir, the wells are going to come back. We have several patterns, as I commented you, like regular 7 spot, 9 spot, direct line, vertical line drive, and the stagger vertical line drive. 5 spot for horizontal wells, and if you want to use your injector as horizontal, you can do it as well. You can create your own custom configuration using custom distribution pattern. Let's say you don't want injector in your pattern, so I'm going to remove the injector and I'm going to add more producer in a crazy way to show you how it's repeated in the other squares. Let's move back to regular 5 spot and let's change the arrow size. You can do it putting the figures in the field or changing directly using the mouse, changing the arrows. Note how the amount of the well changes as long as you change the vector. Let's modify the configuration of the producer. So here you can change the name. In the geometry tab, you can change the perforation. I'm going to set it until the water eye contact, and I'm going to add an offset of 10 meters. For control, I'm going to keep the bottom hole pressure. You can modify for others. Economy limit, I'm going to leave it by default. For injectors, what I'm going to change is the prefix name in order to differentiate the from producers, and I'm going to keep default the rest. Check which development strategy you are going to add the new wells and apply. The wells are going to be created, and also a well filter is generated that allows you to locate the new wells in an easy way. Like this, if we check they are the same as the well pattern design, we can check it in the 3D window, activating the well filter. Here they are. Let me uncheck the grid to visualize it better. Let me increase the perforation size to better visualization. And here they are. So if we zoom in, we can see how the producer are honoring the offset I set, but we can also verify it using the well section. So here they are. This is the producer with the offset from the water contact, and the injector doesn't have because I didn't set it up. Let's check now the well data. The perforation for the new wells are going to be included automatically in the well structure table you define. The same for the strategy. The new strategies are added for the new injection wells and for the producers. So it's time to set our dynamic case. It's just changing or updating your strategy with the new wells, and then we can initialize. Let me put a name, verticals, and now we can run it. So meanwhile it's running, we can visualize the results on the fly. So I already have this template to evaluate these cases. So for wells, for all the wells, for field, we have here the numbers injector and how it's injecting. The same for producers, the amount of producer for this case and how they are producing and the water rate. In the same way, we can visualize 3D properties, calculate the 3D properties on the fly. So for example, I would like to display pressure. We can see how it changes as long as the simulation goes. We may use another feature to evaluate our case, like string lines, to see how our injector are influencing our producer, string line in 2D as well. You may use, for example, bubble map to see how they are producing and injecting your wells. Fine. So let's move to the optimization part. How can we use this tool to optimize it? So here this is our model, and this is our existing well for this example. What I did is I created a binary property, which one is the security distance of 300 meters from the connections. And then I draw a polygon surrounding it. So if I activate the well placement, you can see that the infill wells are going to be located inside this polygon. And no matter how I change the arrow, they are not going to touch my red area. So I'm going to duplicate this pattern, which is 5 spots using horizontal wells. And now it's time to set the optimization parameters. So how to do it? Basically, is adding parameter here in the variables panel. I'm going to add the arrow 1, which is for the size of the arrow 1 of the vector. Going to set the minimum and maximum values and a base value. And then I'm going to assign this parameter where it corresponds. In this case here, know how it's taking the base value. Well, this base value, well, this value are going to be changed by the optimizer inside the limit you set. So I'm going to set it to arrow 2. Fine. What I did the same, I repeated the same procedure for the rest of the parameters. Here they are. I added some parameters for the trajectories and for the offset. And also the arrows I used. So let me show you where I included these parameters. Here in the trajectory of the horizontal, I include the azimuth, the angle, also the distance from the roof, and the offset from the water content. Then I change the control by group, and that's it. For the injectors, what I did is that I included an offset, but this time it's coming from the bottom. And the control is that they are all controlled by group control. So it's okay. Be aware of which development strategy you are going to assign the new wells, as well as the well structure table, and add to workflow. This is going to add this pattern to this configuration to your active workflow. You open your workflow using this button, and you will open the workflow editor. Here is my active workflow, which include geological uncertainties, like, for example, the ranges and the seed for the variogram. Here is the well placement command, which was added, as well as these parameters, they were added automatically. To keep it simple, I'm going to create a new workflow, which is going to be called new in fields, and I'm going to repeat add to workflow, and it was added. The same as the parameters. In addition to this, you can add another commands using this panel. So for schedule, I'm going to add group production and group injection controls, because I would like to add a parameter for the field production and field injection. So here I add that I want for field, and I'm going to look for the liquid column. And it's just a matter of right-click, add variable, and then you set the limit. Note that it's set by default the name. If you prefer to change it, you can do it. Then this is going to be added into your variables panel. I'm going to repeat for the injections, for field, water, control by rate, and then I'm going to add the variable. Set the limit. It's okay, and now it's added. So our workflow is ready now. It's time to set the dynamic case we are going to use. I have a base model. We have historical data already run. Let me show you. Over. So I'm going to use it. I'm going to create a forecast case, taking the last value of the existing wells. So right-click on their case and create forecast. Basically what it does is it restart case and create the roaming strategy with the last values of your existing wells. So I'm setting take please the bottom hole pressure for water injectors and producers. That's it. Note like the time slider was increased. Let me check the strategy to show you. So the new rule were added with existing wells and taking the last bottom hole pressure, the same for the injectors. I took this strategy and I modified it a little bit. I changed the well production limit to group control, and I set the bottom hole pressure to minimum, the same for injector, and I added a drilling queue rule for injectors and another drilling queue rule for the producers. Then, well, I come back to my restart case and I'm going to update my strategy. Fine. So now we are ready to launch our workflow to the HAM module. So for this, we click in the magic bar to create an HAM project. You set the name. Save the project, please. The first thing it's going to show is that the algorithms that you have available. You have experimental design and optimizers. So I'm going to start with 10 Latin per Q simulation runs for screening and validation. They are you can visualize them in the calculation tab, and you may increase the amount of simulations simultaneously. If you want to check your runs before finishing, you can right-click, write result, view result, and then the simulator graphical interface is going to be open. And here you can check how it's running. So it's producing, but I would like to validate my drilling queue. So I'm going to display number of producers and injectors. So it's okay. I set 60 days for drilling wells, so it looks fine. I'm going to close it. Another thing that you can do is that you can visualize results directly in HAM model. So here in the graph plot, you can visualize all the vectors for all your variants, like rate and totals. You can also visualize them in a table, how the variables were sampled. And for particular cases, you can visualize how the variables were sampled for this. For this variant, I would like to check because it has high offset, T1, and high angle, so it's a good variant to validate that the workflow is taking all the variables fine and to check if everything is correct. So again, I'm going to use simulator graphical interface to visualize the result for this variant. These are my existing wells. If I move the time slider, the new wells are going to appear, and then they are going to be open according to the control. Fine. So let me take off the grid, draw trajectories, change the vertical scale, and I'm going to look for a new well that shows me how it's taking the deviation angle. So here they are. We have the well 729 and 732. They are showing angles deviation. Fine. So I also would like to validate how, if it's taking the offset or no. So for this, I'm going to create intersections. So I take here, click here, and I'm going to create an intersection between these two injectors. Like this. I'm going to display it in the 2D window here, cross section. And here we can see how the connections are open along the time. And actually it has a very large offset from the bottom. So if I would like to do the same for producers, I just move the intersection like this. I come back to 2D window, and then these two wells are going to appear. If I move the tiny slider, the connections are going to be open. Here there is a T1 and offset from the water contact. The same for this well. So it's okay. Everything is fine. So it's time to create our objective function for our optimizers. So here there are objectives by default, objective function by default. I want to create a combined objective function considering the total oil and the total water. So let me change here the type, forecast optimization, to keep it simple for field, oil total, and I'm going to repeat to add in another term for field, for water total. Note that for water total automatically is going to be minimized, and for oil total is going to be maximized. But I also would like to minimize the numbers as well. So I'm going to create a new vector using my graph calculator. Graph calculator allows you to create any objective function that is not available in tNavigator. So it's very flexible. And it's simple, like this, calculate, complete, perfect. So let me create my objective function, which is going to use this vector for forecast optimization, user graph, and take my vector. Here it is. You can see for each variant case, we have different amounts as well, and following the drilling cube. So we can also look at this objective function using the table to sort it. But let me first delete these parameters to clear it. And then I'm going to add my two objective function, and then we can sort it. Perfect. So let's launch the optimizations. I'm going to select my initial population data. I'm going to create a new experiment. So we have available several optimization algorithms. And I'm going to start with differential evolution using global search to avoid local minimum. I'm going to select the combined objective function, but I would like to use the number as well also. So I'm going to click on multi-objective function, and then I'm going to add it. So here, what it's going to do is to honor both objective functions simultaneously. Okay, and I'm going to launch. Let's move to result analysis. So I launched several experiment optimizers. Well, here they are all finished. And well, here we have is the neural network-based process generated by the artificial intelligence optimizer I ran. This is a very powerful algorithm that allows to converge the objective function much faster than the other optimizer using this proxy. Actually, for this example, it was needed the half of simulation runs that are used by the other optimizers. We can use the crossplot to visualize parameters. Like this, I am visualizing the two objective function I created, and we have kind of creaming cube over here. So I'm going to select this case because it's where it'll start the plateau. So to evaluate it completely, I'm going to tell tNavigator that please rerun it, but this time run it in a write all mode, please. So what it's going to do is that it's going to run it again, but this time this output is going to include a 3D result and another vector. because, well, by default, tNavigator output only the wells vector in order basically to save space. But if you are interested in one, you just rerun it, and then, if possible, to open it using the simulator graphical interface. And then you can use it to visualize and evaluate and use all the main features or the features that are available in the simulator graphical interface, like water flood, streamlines, bubble map, and so on. Perfect. Let's look at how are the wells for this case. So they look pretty deviated, and there are just a few. So it's okay. Another thing that we can do is to evaluate how what are the ranges that are more used for the optimizers. So for example, for T1, if almost 0 for the offset of the injector is around 16 meters, and so on. But also you can do it only for the best cases. So if you prefer, you can select the best cases in this way, right click, select only this model, and then the histogram is going to be automatically updated, and you can see now the ranges for the best cases. Another thing that you can do as well is using the CDF. Let's say that you are asked to provide only 3 cases, or your best cases. So you can use this to select. If you select it, the navigator is going to pick the variant that is closest to the percentile. So you can send it to your model designer and then rerun it for it. So like I'm going to do, I'm going to check this case I like, and I'm going to set this variable to my workflow in model designer. So yes, it's going to replace the base value of my workflow we created at the beginning. As you can see, the base value was changed. Now I can run, and now I can display my new well from my best case like this. So basically, that was the demo for today. In summary, as you saw, well placement tool allows you to generate infill wells and water flooding scheme in a very easy way. It's versatile, you can combine it with uncertainties and other features, and you can try it yourself. Contact your local RSD office for the related tutorial and get a free trial and start from today. So, well, I'm going to pass to Joanne. I hope you enjoyed. I'll be back in a minute.
Thank you very much, Annabelle. Just while Annabelle is having a look at some of the questions, we're running out of time, so maybe Annabelle, if you just pick 2 to answer. And as I said before, just pop your questions into the questions panel, and if we don't have time to answer all of them, we will make sure that we follow up with your question later on. Just to remind you that you can catch up on the webinars on our YouTube page, and to keep an eye on LinkedIn for the next updates. And the next webinar is on Thursday, and that's hydraulic fracture simulation uncertainty. Just a reminder of the webinar times as well for your local time. Annabelle, do you have a couple of questions that you would like to answer?
So yes, Joan, we have a couple of questions. One question is it possible to optimize injection cycles at different dates? Well, yes. Basically, as I did in the demo, with the drilling queue rules, you create dynamic list, and then with these dynamic lists, you can use any keyword you desire for your forecast. So for this, for your case, for injection cycles, it will be W cycle keyword. And then you can add a parameter for it, like let's say the duration of the cycle, and you can optimize it. So yes, it's possible. Let me take another question. And can this tool be used when you want to complete in 2 different formations? Yes, perfectly. Actually, well, in the demo, I show fixed depth to waterway contact, but you can also set horizons. So first, before this, you need to get the horizon for your formations, the top and the bottom. And then, well, you set it in your perforation panel. And for the second formation, what you do is to add perforation. There is a button in well placement tool, you add the perforation and you repeat the procedure. So the wells are going to be drilled along this limit. You can also add offset, for example, so it's completely possible. Well, Joan, since we are exceeding time, I will pass to you. Thank you very much for your attention and stay safe, everyone.
Yeah, thank you very much. We will actually just leave the window open for 1 more minute, just in case anyone wants to finish writing in any questions. And I can see there's a few that we haven't answered, so I'll pass those over to Annabelle and she will follow up with your question. Okay, thank you very much, everyone, and we look forward to seeing you on Thursday. Enjoy the rest of your day.